I'm Anthony. I'm the CEO of Encode and one of the co-founders. I'll be leading this session on Intro to Rust and giving you more of a whistle-stop tour of it, an overview, then a hands-on coding session that we do a little bit at the start. I want to kind of first start by saying, well, welcome back. We missed last week's session, but we're going to go strong today. I think you've put the Intro to Rust event right, Steve, i.e. today. So we're going to go into a bit more in the weeds of Solana. I first of all kind of wanted to kind of ask open questions. Does anyone have any questions that they've come away and had to think about in the last few weeks that they want to ask about Solana before we get started? Anything could be dumb, it could be smart, it could be anything in between. But any kind of remaining questions from a few weeks ago, or things people have kind of, or cool things people have found in the last few weeks, maybe people started building any projects, any kind of general questions. Okay, what is so great about proof history? So we talked about that a few weeks ago. So proof history is effectively, so it's not a consensus mechanism, because Solana uses proof of stake. It effectively is a way to cryptographically prove that a passage of time has happened in order basically to have a clear, I'm going to say this word and I hope it comes out correctly, chronology. I think I probably missed some part of that word. A clear chronology about what's happened, which allows us to more easily effectively more easily have a clear idea of what's going on chain at any one given point and order transactions a lot more easily. So that's kind of what's cool about proof history. Ethereum doesn't have this. You measure time far differently. You don't have a kind of unique sense of time. So it actually becomes a little bit more difficult to know what's happened when and in what order. So yeah, that's a little bit on proof history. How do you properly read the blockage for your question? We will get into Rust, but I thought it'd be cool to answer kind of questions. So I know what properly means, but this is one of the block explorers. This is more of a general stat. Let's see if we can. I want to look at a contract. I want to just pick this. So this is giving us tokens, but I want to see. Okay. Yeah, I do. We can use Sol Scale. It's much better. I've actually been using the general one. So depends what you want to know, TM. Obviously, this is kind of a look at. I want to just look at a general address. Actually, should we look at the StepN address? Anyone that doesn't know. Oh, sorry. It's because my screen's quite wide. Forget about that. Has anyone seen StepN, by the way? Very cool walk to earn project, doing extremely well on Solana at the moment. Yeah, pleased to say we did actually invest, which is nice. Let's look at. I think let's look at the GMT token. Okay, we'll come to those questions in a moment. So what we can see a record of all transactions. This looks a lot like Etherscan for those of you that know it as well, which is the main Ethereum one. So what can we see? We can see all transactions happening. We can see addresses. We can see therefore the history. Is it really decentralized? We'll get to that in a moment. We can see analysis of holders. We can see who the holders are. This is obviously the treasury of StepN, by the way. Yeah, see any address which is the holders, and we can also see the token program, which I want to show, which shows me basically for this effectively smart contract. Also we can see the rent epoch. We talked about rent before. We can see anyway. We can see a lot. So if you want to have a play around, feel free to have a look at SolScan. Cool. What else can we take? Code for StepN. Sorry, I don't have one. Is there a way to create non-winter custom program? Okay, we'll talk about it later. Is Solana really decentralized? So it depends how you define decentralization. Decentralization is a spectrum. What you're kind of talking about there is how many kind of well, I guess validators talk about, or how many people are actually confirming transactions. Again, it's a spectrum. Solana has had some issues in the past, but it is a blockchain early on in its history. So, so hopefully that answers. Programs of state are being separate. Solana. What is the benefit here compared to Ethereum, where states are being retained the contrary itself? It just makes it run faster in the simplest way, and it's just a different way of doing things, and I think a different way of ordering things for cleanliness of writing code would be the way I'd look at it. What do you mean decentralization is a spectrum? What I mean is that there's no such thing as absolute decentralization or perfect real centralization. I guess perfect centralization is power in the hands of one person, but like in terms of decentralization, what does that mean? Power in the hand of a billion people, 100, 1,000? So in that sense, like decentralization, again, it doesn't have this, like you can say like, if it's these qualities, it's decentralized. It's also a matter of opinion. So clearly you can say something is maybe more decentralized, but you have to define decentralization first. And again, I think consensus works in a different way at the moment in Ethereum and Solana. So at the very least, you can't compare it directly. But I think broadly what people mean is how many validators there are, and also how many users there are, and also like how big the stakes are, like all of these things. I don't know if more decentralization is better. I think this is a more, you start, I think, very quickly to get into socio-political, philosophical issues on decentralization. A little bit of centralization is a good thing, really. In Solana, the best programs are not centralized, but they're written by one person. So again, you can be have centralized in that sense, but still have a lot of people verify that something's good. I don't know. It's up to you what you think decentralization is. I think what we mean in a blockchain context is broadly to protect the value of the underlying token, and also to protect the autonomy of the network. And minimally, we want to avoid 51% attack, someone having more than 51% of the nodes. And maximally, we want to have a system where no collection of actors could manipulate the system. Now, clearly, you have some big kind of Solana holders, quite well-known ones, the SPFs, the Serums, the FTX, the Almeidas, the Multicoins. So Ethereum maybe doesn't have that, but Ethereum is also more mature in its journey. So it's also quite good to have big actors in the early stage that are kind of promoting the product in order to have more people to evangelize it, so more people get involved later. So you can have decentralization, you can have centralization as part of a path to decentralization, really. I've seen plenty of projects these days that's are decentralized from day one, which basically means they gave up. And I'm like, well, that's decentralized, but like it could have been centralized for a short period of time, got a lot of adoption, and then become decentralized, and that would have been a far better way to keep the project going. So that's what I mean. It's a spectrum, it's a matter of taste, and there's no obvious answer, really. That's my very political way of answering that. Yes, I know, that's what I mean. You verify it. You verify by building on it, or you verify by looking at the code. But what I mean is that you should not confuse centralization with relying on a few trusted kind of actors, especially in the early stage of protocols journey. Cool. So this is the third event in our series. This is more, we're taking a step back from Solana and talk about Rust and the design decisions behind Rust, and hopefully it's hard, Rust. I'm not going to pretend it's not hard. There we have got Anchor, we'll talk about later. Anchor is like a more EVM like language, not that Anchor. It's a framework for writing in kind of Solidity. If you are, the easier way is to use Anchor. If you want full control, I think of it like driving a sports car. If you wanna ride, could it go manual, use Rust. If you're kind of happy to be automatic, it's still fast, then use Anchor. I'll put the docs for Anchor if anyone wants to have a look. We will have a talk with them later. Well, first of all, we're going to talk about what is Rust, and it's a programming language. It's the programming language of choice for the Solana ecosystem. Many of the top chains use it, use top here maybe a little bit too aggressively, but the Terras, Polkadot, NIRs, and of course Solana. Polkadot use it for substrates, NIR use it for smart contracts, Terra uses it for smart contracts. Rust is, again, a learned skill, a hard skill, and but there's a few reasons why you'd want it, specifically for a blockchain and smart contracts. The main two reasons are kind of performance and reliability, honestly. We'll talk about what these things mean. In terms of performance, we're talking about memory efficiency, speed of the code running, and also kind of no, for those of you that are more technically minded, no runtime or garbage collection. On the reliability, we want to have a rich type system and ownership model that has memory safety, and we want to try and have it built in, kind of most important thing, built in by design, a way of avoiding bugs as much as possible, especially bugs that could cause problems later. So these two simple concepts we need to think about. We're trying to make something run fast, and we're trying to avoid bugs. Run fast, avoid bugs. This is the dream when kind of writing code. In a sentence, which I stole from a very nice handy book to Rust, it's high-level ergonomics and low-level control. Often these things are at odds in a programming language. And again, like a sports car. Sports cars are the most luxurious things, but you have to kind of you have more control than any others, and therefore more ways things can go wrong. And Rust is trying to challenge that conflict. So we all want to drive a sports car. We all want to drive a Ferrari. This is being very generous to us, probably. With this, if you want to drive a Ferrari, you first need to learn how. But the key thing is, I think, more than the speed, is the bug removing by design. And I think this is on two levels. One, it forces you to think about bugs a lot more closely, using the primitives of Rust. And the second factor is there are certain ways to avoid it. For instance, the compiler, when you're compiling the code, actually will not let you compile it if you have low-level bugs, and it will try and concurrency being one key one, things happening at the same time, especially that are at odds with each other. The compiler itself, yeah, that's true. Absolutely. Other good things, it uses something called Cargo, which is dependency manager. We'll talk about that a bit later, and the Rust FBMT, which is to try to maintain a consistent coding style, which for those of you that I think I was once taught when I did a lot of maths, that elegance is better than any method, because elegance is the best method, and I think that applies in writing code as well. If you can write something clearly and elegantly, it's clears the head and allows you to be focused, and B, it's easy to read and spot errors kind of later. So we'll talk about that. This isn't hands-on, but if you do want to play around now and you do want to open up your terminal, you can run this little bit of code and do your first Rust program. So if you're on Mac or Linux, oh, can someone? That was my voice though. Let's keep muting on. But if you're on Mac and Linux, if you run this code, I'll paste it into chat. Oh, how am I going to paste this into chat? I'll tell you what, I'll go. Oh, I'll tell you what I'll do. I'll do two versions. God, this is so sophisticated. And then I can paste the code at the same time. I'm not going to open terminal up on my screen because my laptop is weird and will definitely not let me do that. So if you want to install Rust on Mac and Linux, do this. Oh, thank you. And if you want to, if you're on Windows, I have the code for you. Cool. So if you run that, it will install Rust, and then you might need a linker as well. And this is a program that Rust uses to kind of join its compiled outputs to one file. You might get errors, in which case kind of run this code. You should be absolutely fine. Oh, there it is. It was on the next slide. Beautiful. And then what we'll need to do is we'll need to kind of start by making a directory to store your code. So you can do it this way. Again, I'll paste the code. And then if you run that, this is the one on Windows, sorry, let me just paste it. By the way, this is all recorded and this is all written down. I'm not expecting anyone to do this at the same time, but if you're running back, This might be useful too. And then you need to create a new source file called main.rs, rs main.rust, and you need to enter the following into it. Formatted terribly. And if you save the file, go back to terminal and run this, it will print hello world. So I'm not expecting anyone to have actually done this. If you have done it, I applaud you. Send a screenshot, put it on Twitter, I will retweet you. But otherwise, it'd be nice if you guys go back and run a basic. Yeah. Oh no, you can't copy this. We need to avoid that. I don't know how that is an issue. Okay, I'm going to show my slides afterwards and then people can do it. So that makes a mockery of doing live code stuff. Anyway, if you run this, you will get hello world in the terminal. And well done. If you're watching this back, you've officially written your first Rust program. I don't expect anyone to do this now, so I'm actually going to talk through the logic of it. So I want to talk through the anatomy of what's going on when you do this, because this is like, are you guys sending the link for the recording? No links will be sent. I'll put my slides up later for anyone that wants to have a look. Do I prefer Anchor? Ask me later. Anyway, anatomy of a Rust program. So first things first, you've got this sort of fn main, which is just a function in Rust. And the function is special because, or the main function specifically, this part here, it's always the first line of code that runs in a Rust program. And it has no parameters, and it will return nothing on its own. And if you do have parameters, they'll just go inside here, inside the bracket. So these squiggly brackets, which you can see here, are obviously very important. This is the function body, again, like other coding languages. This is, you need to use them. It's good style to place them on the same line as the function declaration, and then add one space in between. So yeah. You've also got the Rust FTM, we talked about this earlier. And if you want to have the same kind of style across all your projects, this will automatically format your code for you. It's a standard tool, and it's already installed when you use Rust. So it's just something to bear in mind. Again, I'm not expecting you to install anything now, but just remember this, it will help kind of standardize your code when you start building. And this thing here, so printing hello world. So this is in our little program we did before, this is kind of doing all the work. Where is it? There. It's kind of doing all the work. Specifically, it's doing a few things. There's kind of 4 details I'd kind of like you to note. One is you indent with 4 spaces, which the formatting has killed. Not a tab. Second, this thing here is calling a kind of what we call a Rust macro. If we actually called a function, it'd be entered as println without the kind of exclamation mark. Macros are kind of important thing to note. We won't talk about them so much today. All you need to know that if you use exclamation mark, you're calling a macro instead of a normal function. Third, you'll see this is a string. You're passing the string as an argument, and the string is then being printed. So like strings will be familiar to you from normal coding. And also, if we end with a semicolon, it indicates the expression is over and the next one is ready to begin. So just remember that most lines of Rust code will end in a semicolon. Cool. Other thing to note, and this is important from the bug aspects, compiling and running are completely separate steps in Rust. And again, we're trying to make sure that we catch bugs as early as possible. And again, it's 2 ways to think about it. One, methodologically, or sorry, no, from a approach point of view, it's trying to treat you to be very cognizant of bugs, and also it's kind of a net to catch errors. So next, we've got the sort of next thing, which is the this thing. And if you're from a kind of C or C++ background, you'll notice this is really similar to GCC or CLang. And if after compiling successfully, Rust will kind of output a binary executable. And on Linux, Mac, PowerShell, if you're using kind of Windows, you can see this executable by entering the ls command. So nice little cool one for anyone that wants to use this. And we will not do the Windows stuff now. Yeah, or Haskell. We'll do it a bit later. So I want to talk about cargo. Cargo is really interesting. I mentioned it before. We go all the way back. So it's a dependency manager, and I think it works kind of quite nicely. There we go. So cargo is kind of package manager. By the way, does anyone know what you call a Rust user? Fun points if anyone gets it. You can guess if it's not obvious. So yes, great. A Rust station, like a little crustacean. I find it quite funny. Most has anyone used cargo before out of interest? Omid, you're on fire. Why are you here if you know Rust? Very good. Most Rust stations, I guess you guys are going to be Rust stations very soon. Use this tool to manage Rust projects because cargo will do a lot for you. It'll help you build code. It will help you download libraries your code depends on. It will help build those libraries. And obviously, does anyone know what we call libraries that your code needs? Anyone know what that's called? Yeah, kind of. Just dependencies. And so we wrote like a very simple, although if you do come back to this, you're watching on YouTube and you're looking over it, you've just written a very simple Rust program. So we don't have any dependencies, like we're just printing a string. But if we built it with cargo, it would actually only use the bit of cargo that handles kind of building code, but we can do so much more. As you write, and the whole point of Rust is to write, they're clearly having fun. Very good. I don't know. General rule, I'm sure that's a nice link. Don't click on random links in chats. Maybe someone from our team can check it's legit. What was I saying? You've made me lose my thread. As you kind of write more sophisticated Rust programs, and as you start doing it in Solana, we've not really talked about Solana yet, you will add dependencies, and you'll want to make things more complex and add logic. And if you start using cargo, it will make things much more easy. Cargo luckily comes already installed with Rust, and if you do it the installation process properly, you'll be absolutely fine. Cool. You can actually check if you've got the right version of cargo. Okay, just developed here. Very good. If you can actually check if you've got the right version by just running this. Again, I can post it in chat, but that won't mean anything. So you'll have to kind of copy it out onto the screen when you are doing this later on. But it will show command not found, obviously, if you don't have it. So just check the docs and you'll be absolutely fine. And actually, by the way, I think a good skill of a good coder, I've learned more and more over time, is ability to problem solve very fast and to look at docs. And that kind of sounds like a cop out, but it's kind of an essential skill, is knowing how to dig your way out when you've got a problem. If you were like creating a new project using cargo, you'd do it like this. And it's a little bit different to that Hello World project we just looked at. The first command here is creating a new directory called Hello Cargo, and we've named our project Hello Cargo, and cargo is creating its files in the directory with the same name. And if you actually go later on and look into that directory, you'll see that cargo will have generated a couple of files for you. One is something called a .toml, and the other is an SLC directory, which will have our main RS Rust file inside. And it also will initiate a Git repository for you, as long as with a Git ignore. So it's doing a lot for you for free. Another one of the nice things straight out of the box. I might not go into this so much now, but if you want to kind of open up the kind of the toml file, does anyone know what toml means? I'm definitely saying it wrong. TOML. Anyone know? It's quite funny. Tom's obvious minimal language. Don't want to play around. So the file is in .toml, which is the configuration format of cargo. I'm going to put some extra stuff in the presentation afterwards because I've actually not got a million amounts of time. But anyway, by the way, another kind of advantage of using cargo is that the commands are the same on every operating system, which means that a lot of time when you're using cargo, and if you look at the kind of Rust docs, you don't therefore need to kind of differentiate between Linux, Macs, Windows, etc., Mac OS. Windows, etc. And look, honestly, if you're building very simple things, projects that like printing strings, you don't need to use cargo. You can just use Rust C. But if you do want to kind of build complex products that have crates, you probably want to use cargo. You definitely want to use cargo. Good luck trying to build without cargo. And by the way, if you want to have another look, if you go into the SLC main RS, you'll see this. Basically what cargo has done is generated a hello world program for you, just like the one we wrote. We kind of had a look at the start of this presentation. Is there a go, I suppose? I'll take this in a second. So far the kind of differences between the kind of easy product we build and the slightly more cargo complicated one is that what cargo has done is place the code in the SLC directory, and we also have a cargo.toml configuration at the top. And cargo kind of expects that your source files will live in the SLC directory. It's kind of organizing it for you. And at the top level directory is just for like README stuff, for licenses, configuration files, and anything else like not related directly to the code itself. Using cargo, therefore, is kind of helping to organize your projects, and it's defining a place for everything. And again, this goes to the methodology of Rust, which is trying to make you structured, make you organized, elegance, make things much easier moving forward for everyone. And also very important for when you build Solana applications. And if you start a project cargo, if you use a starter project that doesn't use cargo, you can actually convert it to be a cargo project. You just move the project code into the SLC directory and create a normal cargo.toml file. Cool. I will take questions in a little bit. So I want to talk through, this is kind of a like nice whistle stop on like write some little bit of code, but I kind of want to talk through the concepts because they're the most important thing. I will take Blueprint's question quickly. Is Rust purely for smart contract development? Yeah, pretty much. Remember, what do we call smart contracts in Solana? Does anyone remember? Programs, very good. We call them programs. We like programs. Cool. The most first thing is to talk about variables and immutability. Again, I want you to keep thinking in mind this sort of, I'm going to keep saying it. It's trying to force you to take a certain approach with Rust, and it's also giving you a few kind of default options to make sure you stick by that approach. So it's making you think cleanly and making you think in a way that avoids bugs, and it sort of makes your code reliable, but it's also kind of setting some defaults and setting a structure to make sure that happens. So the first thing to talk about is variables, and it's, I would say, mutability. In the docs, it's immutability. So by default, a variable in Rust is immutable. So you might be like, what? Really? And this is a nudge. Rust is all about nudges to write code that is safe and that there's no problems with concurrency. You still can make the code. You still can make the code mutable. You just have to define that. We can also talk about a little bit why it's gone down this way. If one part of our code operates on the assumption that the value will never change, and another part of it changes that value, like obviously what's going to happen is that some bits of the code will start not working unless you've been incredibly safe about it and you know what you're doing. But especially as you kind of, Rust is hard, you're learning it from scratch, and you're going to make errors. And then you got to spend so much time tracking down the bug, and this is problematic. So the Rust compiler will guarantee that when you state a value, it won't change. But when you state a value, it won't change, it really won't change, which makes your code easier to go through later. Mutability is, however, possible. You just use let mute x equal 5, this kind of mutes bit. And obviously you want to make stuff mutable. It's important if you're building complex logic. Variables are only immutable by default. But if you just add mute, it will make them mutable. So again, not trying to go deep into the writing code here, just going to talk you through conceptually what's going on. Also, adding mute conveys intent to future reads of the code, that other parts of the code will be changing this variable's value, which I think is kind of important to know as well. You've also got things called constants, and a bit like immutable variables, constants are values that are bound to a name that are not allowed to change. Such as this on screen at the moment. But there are a few differences between constants and variables. First, you can't use mute with constants. You can't use mute with constants. Mute being like mut. It's not mute, it's mut. I'm going to call it mute. Constants aren't just immutable by default, they're always immutable. So key difference between a constant and a kind of variable. A variable are immutable by default, but can be made mutable. And a constant is always immutable. It's constant. You declare constants with this little thing here, const there, and instead of the let like we used before. Yeah, so the let here. The type value must be annotated. We're going to talk about cover types and data types. Constant can be declared in any scope, including the global scope, which makes them useful for values that many parts of code need to know about. And the last difference you should know is that constant may only be set by a constant expression, not the result of a value that could be computed at runtime. So here we've got a constant name, 3 hours in seconds, and its value is just the result of multiplying 60 by 3, which is, again, minutes times seconds times 3 hours. Rust's naming convention for constant is to use all uppercase, note, with underscores between the words. And the compiler is able to evaluate a limited set of operations at compile time, which lets us basically choose to write this value out in a way that's easy to understand and verify, rather than setting this constant to the value of 10,800, I think it is. Cool. And constants are valid for the entire time program runs within the scope they were declared in. This basically makes constants really useful for values in your application domain that multiple parts of the program might need to know about at any one time, such as if you're building a game, the maximum number of points a player can earn, or again, just constant values that are going to be useful later in your smart program and later your smart contract. And obviously naming these hard-coded values is really useful in order to get quick, clean, elegant code that isn't going to cause problems later. You've also got a thing called shadowing. This is where you declare a new variable with the same name as a previous variable. Rustations say that the first value is shadowed by the second, which basically means the second variable's value is what the program sees when the variable is used. And we can shadow a variable by letting the same variable using the same name and just using the let keyword. And it's different from marking a variable as mute because you'll just get a compile time error if we actually try to reassign this variable without using let. And again, this allows us to perform a few transformations on the value, but have the variable still be immutable after those transformations have been completed, which again just means for safer code. The only other difference between mute and shadowing is that because we're effectively creating a new variable when we use this let keyword, we can change that type of value but reuse the same name. For example, if our program asks the user to show how many spaces they want between some text by putting space characters, then we might want to store that input as a number. So just nice to know this difference between let, mute, constants, immutability, and kind of changing values later. And now I want to kind of talk about data types, which I think is also every value in Rust has to be a type of data type. This kind of makes sense. And this tells Rust the kind of data and what it needs to do with it. We're going to look at two broad types, scalar and compound. And keep in mind that Rust is a statically typed language, which means it must know the types of all variables at compile time. So first, we've got scalar types. So scalar types represent a single value. Rust has 4 scalar types. Does anyone know the 4 out of interest? Yeah, good. Float, bool, yes. Yeah, characters, good. Integers, yes. Yeah, I pretty much got that. Well done. So you've got integer types. So an integer is just a number without a fractional component. This declaration indicates the value that's being associated, obviously. And you can each variant can either be signed or unsigned and has an explicit size. Signed and unsigned here refer to whether it's possible for the number to be negative. In other words, whether the number needs to have a sign with it signed, or whether it could be positive and therefore it can only ever be positive and be represented without a sign, which means unsigned here. It's like just writing numbers on paper. When the sign matters, we use a sign. When the sign doesn't matter, we leave it unsigned. Each sign variant can store numbers from, this is kind of not needed, but like as little as -2 to the n minus 1 all the way up to 2 to the n minus 1. -1 inclusive, where n is the number of bits the variant uses. Kind of not needed. You can write integers in any form, a lot of forms you like, and I should, if I could do it in a nice way, I would copy and paste some things you know now, but not. Integer types, obvious ones. Floating point types, these are kind of 2 types of floating point numbers, which are basically numbers with decimals, kind of really important for crypto. The floating point types are F32 and F64, which is 32 bits and 64 bits in size, and the default type is 64, based on just modern CPUs. And they're all signed, obviously, because you kind of need to know if they're positive or negative. We also, this is not a type, but it's just important to note, you can, Rust supports several types of numeric operation, addition, subtraction, multiplication, division, remainder. And if you do use division, it will round down to the nearest integer. So yeah, kind of important to know. I've also got Boolean types, so true and false, and they're 1 byte in size, if you want to know. And you specify it using bool. And of course, you've got character types, and this is just the most basic kind of alphabetic type, which you use by declaring the char value. You also then have compound types, and compound types can group multiple values in one type. And we broadly have 2 in Rust. Anyone know what they are? Yeah, cool. Well done, Peter. Tuple and array. Very good. There's enough time to Google at this point, but magic march well. So obviously there is a tuple type, a tuple type. I never always get that wrong. And this is just a general way of grouping together a number of values with a variety of types. You look at the manual. Very good. The manual is good. Yeah, the manual is great. I'm going to paste the link. I didn't want to kind of, it's what I use, so I didn't want to kind of give people the answers too soon, but everyone wants to follow along. So yeah, it's just a general way of grouping together a number of variables with a variety of types into one compound, and they have a fixed length once declared. They cannot grow or shrink in size. We also then have where's my arrays gone? Where's my array slide? Oh, what a disaster. Well, I'm going to use the docs. My array slide has clearly been deleted as I made these slides. I will see if I can find it. Maybe I reorganize it. Anyway, the array type is just another way of collecting multiple values. Unlike a tuple, every element of the array must have the same type. And unlike arrays, in other languages, arrays in Rust have to have a fixed length. And we write them using a kind of comma-separated list. So yeah. You also have this. Anyone know what this means? Very good. It is a comment. Who is good at writing comments here? Who writes a lot of comments? Just to answer your question, Ryan, so a tuple, a tuple will group values with a variety of types. Arrays will group them by a single type. Not me. Very good. So yeah, again, key thing for us, we're trying to make things elegant by design. Wants everyone to strive with empathy. And we strive to make this easy to understand by writing comments, explain what you're doing. And this is how you write comments. Use this to write comments in Rust. It's the idiomatic style is to use 2 slashes, and the comment continues to the end of the line. If you are going to extend beyond a single line, you should use these for each line. Just a kind of strong piece of advice, really. In terms of control flow, this is the ability to kind of run code that depends on a certain condition, and this is kind of incredibly important. As we write smart contracts, control flow is unbelievably important. It's like the whole point of smart contracts is control flow. And this, again, running code based on the condition something is true, or running some code repeatedly while a condition is true. Loops, for example. And the most common one is, anyone know the most common control flow? It's kind of obvious. Yeah, if else. Very good. You win the golden Mars bar. I don't have to say your name. Here's an example. I should have done this for all of them, but I got a bit lazy. So if the number is less than 5, print the condition is true. Else, again, if anyone's familiar with most other languages have this. What the expression is allowing you to do is branch your code depending on conditions, fundamentally, if we're going to say it in nice, elegant speak. And you provide the condition, then states basically, if this condition is not met, run this block of code. And if this condition is if this condition is met, run this block of code. If this condition is not met, do not run this block of code. And obviously, you can nest ifs and else in with each other as well. What is very important is loops, and loops are basically blocks of code that kind of keep running, that execute more than once, and there's 3 in Rust. I'm not going to go through them now, but loop 1 and 4 should be fairly obvious for those of you that have done kind of control flow work, which is pretty much everyone, what these might be used for. Again, we've kind of given you the core stuff, but there's a kind of lot of fundamental features, so I've left myself no time to cover, which I'm now going to have to speak through, which is really annoying, but hey ho. The first is a struct or a structure, and this is a custom data type in Rust that basically lets you package together and name multiple related values that make up a meaningful group. And if you're familiar with kind of object-oriented languages, a struct is like an object's data attributes, effectively. They are different to tuples, there's also these things called enums, which we'll talk about a bit later, they basically allow you to take advantage of Rust's kind of compile time type checking, if you're kind of familiar with what that is. Again, we've also got these things called enums and pattern matching, and these basically allow you to define a type by enumerating its possible variants. You also have these things called kind of options, and then you can use if let as well, nicely here. Enums are in many languages. Has anyone ever used enums before in other languages? I know we have a Haskell fan. Yeah, Ocampo as well. They're most similar to kind of algebraic data types in things like Haskell, Ocampo, but yeah, very good. You've also got modules in Rust, and when you start writing programs in Rust, your code might, you think, live solely in the main function. This would be bad. Your code would grow, it'd get ugly, and more prone to bugs. What we want to do is split our code up into smaller chunks, each chunk being easier to understand. Rust has its own module system that basically allows for this, and in the same way that you extract lines of code into a function, you can extract Abby, that's a nice way to think about it. You can extract functions into different modules, and the module is just a namespace. Exactly that, Abby, that contains definitions of functions, of types, and you can choose whether you want these definitions to be visible outside of the module, might be public or not, might be private. You use the mod keyword to declare a new module, and the code within that module appears either immediately following this declaration or in another file. So that's a nice way to kind of think about it. So Rust standard library includes a number of data structures called collections, and they're really useful. And most other data types represent one specific value, but collections contain multiple values. And so unlike array and tuple types, the data these collections point to is stored on the heap, for those who know what that is, which means the amount of data does not need to be known at compile time and can shrink or grow as the program runs. Each kind of collection has different capability and costs, and choosing one for your different situation is a skill you will learn as a Rust developer. There are 3 kind of things to think about. A vector allows us to store a variable number of values next to each other. A string, as we know, is a collection of characters, and a hash map allows us to associate a value with a particular key. And again, we're starting to get into almost crypto concepts here. Error handling as well is a very important thing we've talked about throughout this, and Rust's kind of commitment to reliability extends to the way we kind of handle errors. And obviously, like, errors are a complete fact of life in building software, and Rust has a number of kind of features to kind of avoid this, which we've already talked about. And in many cases, Rust requires you to acknowledge the possibility of an error occurring and take action before your code even compiles, as we talked about, by splitting the compiling and the running. And again, we're trying to make our code more robust by ensuring that you will discover the errors way before production. There's two kind of broadly categories of errors. One is recoverable errors and unrecoverable errors. And recoverable errors are kind of situations in which it's reasonable to report the problem to the user and retry the operation, like file not found. Unrecoverable errors are symptoms like of bugs and trying to access location beyond the end of an array, for instance. And obviously, most languages don't really differentiate between these two types of errors, and they handle both in the same way. Rust, and they use exceptions. Rust doesn't have exceptions. That's kind of, it says you can use results TE for recoverable errors and panic, exclamation mark, macro that stops execution, which you'll find out later. It's worth knowing. It doesn't have exceptions in the traditional sense. I haven't talked at all about Solana, and that's kind of intentional by kind of allowing you to get to grips with kind of the idiosyncrasies of Rust itself. But armed with this knowledge, you can actually start playing around, go back to the Solana docs and play around, and you'll notice the first thing you see is a cargo.toml and Solana programs, again, like Rust programs, act much in the same way. Solana does have a particular opinion of Rust, but one of the opinions is that you use cargo by design. As we can look in later weeks at stuff, and if you ever do our bootcamp, we'll take you through the kind of Solana way of looking at Rust. But you kind of do need to know some of the fundamentals of Rust to kind of get started. And then kind of putting it all together here. Again, Rust is difficult, it's hard, it has certain opinions. Maybe I'll stop sharing my screen now. It has certain kind of strong opinions about the way we do things. That's all centered around fundamentally error handling, reliability, and therefore performance. And I've really focused this talk on, I think it takes a kind of particularly skilled developer to get the best out of Rust, but it takes a fairly competent one just to get the best out of it in terms of reliability. Speed comes later, reliability and kind of avoiding bugs is the most important thing. I think this is one of the reasons, particularly as you can see as we build smart contracts, why you might want to avoid bugs, because errors in smart contract, bugs in smart contracts will be terminal and kind of lead to lots of money being lost. Now my voice is totally dying as we reach the end of the hour, so thank you very much. Yeah, JS is also annoying. And again, every language has an opinion. Is it foolish for a junior to become a Rust developer? I don't know. I don't think there's. I think it's a good question. I think the upside is bigger on Rust, but the standard needed, it's a bit like Solana, but the standards need to be is higher to kind of get started. So I would, if you're a new developer, I don't know, try it, see what you think, maybe you like it more. And there's certainly other reasons why you might like it more, quite frankly, that go beyond the ease of use. Maybe just because like you like the fact it's difficult and you can kind of establish a niche in it. Any good resource? Yeah, some good ones. We talked about some earlier. This is good by Nada. This is colorful. Yeah, and there's also one more. The cookbook's pretty good as well. Otherwise, thank you guys. Slides video will be up tomorrow. It's been an absolute pleasure as always. Hopefully it's not scared you off Rust. It's been a fairly nice introduction, I think, easy introduction. Look forward to seeing you in future weeks, and I hope you do ping us anytime. I'll drop my email in if anyone wants to ping me directly. Alrighty, thanks guys, have a good day.